Hey everyone, thanks for waiting. We will be starting shortly. Let's just wait for a few minutes. Till then, just let me know if I'm audible and my audio is clear and everything. Hey everyone, I hope I'm audible. And let's begin. First of all, welcome to the stream. And this is our second Cloud Studies Jam. Today, again, we will be completing our labs that we left in the first quest. So let's get started. First of all, just a quick recap. As you all know, we have two tracks, and our first track is Cloud Engineering one, and we are currently working on the first one, which is getting started, create and manage cloud resources. So let's get started with a quick hands-on. And just before we start, just a quick tip: please make sure, like whenever you are attempting any lab or anything, please open an incognito window, or else there might be some issues like unwanted billing at all. So our first track is getting started, create and manage cloud resources. And in this quest, we have these six labs. The first five one are we will be covering them in the Cloud Study Jam, and the last one is a challenge lab, which you will have to do on your own. So here was the first one, a tour of quick labs in Google Cloud, which we have already completed. In case you haven't, you can always watch the recordings. And the next one is virtual machine. We covered this last week. Sorry, in our last meet. And next one is getting started with cloud and G-Cloud. We also covered that previously. So here's how our progress looks for now. We have completed three labs and we have still two more to go. After that, the remaining one will be the challenge lab, and you will have to complete that on your own. But still, we can have a doubt session on Sunday in case you have any doubts or you are facing any issues with the challenge lab. So let's begin. Today's first lab will be Kubernetes Engine, a quick start. And basically, the objectives of this lab will be to create a Kubernetes cluster and deploy an application in the cluster. First of all, let's talk about why do we need this Kubernetes engine. And before talking about clusters, let's talk about containers. You guys must have faced this thing, like let's say that you wrote a Python script, and like most of your first year people are learning Python. So let's say you wrote some Python script to attend your online classes, okay, and you shared that script with your friend. Now, that script is not working for your friend, but it runs perfectly on your computer. Your friend says, "Hey, this is wrong code, or this is not working. It's causing some errors or anything." So here's the thing: like you wrote the script and it's working fine on your computer, and you are running on Windows 10 with Python 3.8. And as you know that Python 3 scripts are not supported. Like many of Python 3 scripts are not supported on Python 2.7. So it just won't run on your friend's computer, and debugging all of that, like testing what's the issue, is there an issue with the OS or some DLL file or anything else. That's so painful to be honest. And now let's consider like you are working in a production environment for a company, and you are using, remember we talked about Nginx servers last week, sorry, in our last session, Cloud Studies Jam. So let's say that you wrote some application and you are using Nginx 1.15 on your system, and your code works perfectly fine. But when you deploy it to production, when you send it to your company, they are using Nginx 0.4, the older version, and it just doesn't work. Also, the database don't match. In these scenarios, it is like it's so time consuming to actually debug all this and make sure that your code works on production side. And see, to fix all these, we use these things called containers. Now, what is a container? A container actually just includes your application code along with different dependencies. Let's say, like in the previous example, remember we were saying Windows 10 with Python 3.7, and your friend's computer had Python 2.7 or something. So in cases like these, what you can do is, instead of just sending your code, you can send your friend a container, and that container will include a pre-installed version of Python 3.8 along with the code. So whenever your friend tries to run that same app, it works like a charm. It works without any errors, without any incompatibility issues. That's what containers are in the simplest terms. And to create repeatable and reliable deployments, you can consider packaging your cloud native applications as a Docker container image. Docker is one of the most popular container services which is out there. You can always Google it and you can know more about it. Now, what we can do with these containers is there's this service in the cloud called Google Container Registry. It's under it's under a subsidiary part of Google Kubernetes Engine, and you can just send your image, your container image or your Docker image to this service, and it will take care of the rest of the things. So now let's imagine that you are in a company and you are a maintainer, and you have around, let's say, 20 or 30 developers. Now all of them are working on their projects and they send you their code in form of their containers. Okay. Now to deploy all these, let's say there are 30 containers. Now to deploy all these 30 containers, it's such a cumbersome job. Like you will have to deploy each container in each virtual machine manually, and that's just so much time taking, time consuming. So in these cases, we use Kubernetes. Kubernetes is just a simple service. It's an open source platform that orchestrates or divides compute, network, and storage on behalf of your application. It contains a cluster. A cluster is just a collection of a bunch of resources, bunch of virtual machines, and there are nodes and other compute engine virtual machines instances that Kubernetes process in necessary to make them a part of cluster. And Kubernetes is just a managed service of Google Cloud's Kubernetes Engine, and it can help you in rapid deployment and all. Actually, I have shared a link for a video in Slack. In case you are in Slack, please join our Slack, and you will and actually you can watch that video to get a very clear look at what Kubernetes is, get a detailed look. So enough. That's all about theory for now. Let's just jump into a browser. Let me just open my browser, and I hope you are able to see this. Let's go to our Quicklabs account, google.quicklabs.com/quiz/120. I will also share the link in the chat. Yeah. So right now we have completed these 3 labs, and we will start with this Kubernetes engine, as I mentioned. Let me just zoom in so that it's visible on mobile screens as well. Sorry, that's way too zoom in. Yep, so here's about this lab. Let's just click Start Lab. We have already gone through all the prerequisites and all the objectives. It's still loading. Let's just give it some time. Come on. Okay, until it loads, let me ask you a quick question in the chat. What was Engine X? We talked about it last night, in our last study jams. Can anyone explain? Does anyone remember what Engine X is? Okay, Chirag says Nginx is a web server. That's correct. Okay, Chirag and Sanchita have given the correct answers. Great, perfect, guys. Let's move on. Okay, Bhavesh. Yep, that's very well explained. Jagreet is also correct. A big shout out to you guys. Thanks. Okay, let's start with the lab. I will just open this, copy this link or open Google Console, and let me just open a new incognito window. You guys know how to do that. Control Shift N or Command Shift N. Just paste this link here. Now we will copy your credentials. First of all, the username. Paste it. Now let's copy the password. Okay. Just click on accept to accept these terms. Click confirm. Just wait for the country specific terms and conditions to load up, and we will proceed. Click on agree and continue. Okay, so here we are. Now let's jump back to our lab manual on how to do this thing, what we have to perform. First of all, we have to set a default compute zone. Now, in case you guys remember, in our last lab, what we did was, actually, first of all, let's just open our shell. In our last lab, we created some variables. Do you remember? We created some zone and other variables for project ID. We can also use that. Does anyone remember what was the bash command? What was the command that we wrote in terminal to create a new variable? I will write that question in the chat. You guys have already answered. Correct one, Chakrit and Chirag. Amazing. Okay, so we can also actually, to set this default zone, what we can also do is we can just create a new variable also. Export zone is equal to US. I think it was US Central 1A. Yep, we can use this Central 1A. Either we can do this, or what we can do is in GCP command line, there's already this command gcloud config set compute zone. You can use this as well to create like to set a default zone for your entire session. Let me just write that gcloud config set compute zone US Central. Let me make sure the spellings are correct. Yep. And with this, we have just set the default zone. It is similar to how we export a variable and just add this minus zone. Sorry. Yep, this variable with all our gcloud commands. And next, we have to create a Kubernetes engine. Where is it? Yep. Okay, so we have to create a Kubernetes engine cluster. And as you can read here, a cluster consists of at least one cluster master machine and multiple worker machines, like we talked about multiple virtual machines. So let's just create one. And for the name, we will be using my cluster. Let's call it my cluster. Let's write the command gcloud container clusters create my cluster. Actually, one more thing that we didn't talk in the last session, it was gcloud interactive data. Someone just reminded me that on Slack, and we will also discuss that later on. Let's just authorize this request. And it's creating a pod service. A pod is basically a container or a cluster on top of all its dependencies, and a pod contains all the network configurations, the compute resources, and everything. Let's just wait for this to deploy. It takes a little bit of time. Let's just wait. You can also do, like we are currently using the gcloud terminal to do all this, but you can also do this manually. I mean, using the web UI. And right now it's just checking the health of our cluster, like if everything is working fine or not. This typically takes around 40 to 60 seconds. Let's just wait, and once we are done, we can check our first task in our lab manual. Come on. Let me click refresh. Okay, until it does, let's just take a look at what we have to do next. Once our cluster is running, we will click this check my progress button. Make sure to do that. And until then, let's just see what we have to do next. Next, we need to get the authentication credentials for our cluster. Okay, so what this means is we basically have to log in or connect to our cluster. Like, remember, we used to SSH into virtual machines previously. In a similar way, we will need to connect to a cluster, and to do that, we need some authentication credentials. So, like, because we don't want any random person on the internet to access a cluster, and cluster is basically a combination of machines. We don't want people to have access to, let's say, hundreds of my computers without any password. So we need some strong authentication. We will use this command to get the credentials. Let's see if our cluster is deployed it. Yes, it's running. And to get the credentials, either you can type that command, which is mentioned in the lab manual, or you can just click this connect button. It will get the authentication credentials and automatically log in. But for the sake of this, let's not make things difficult or confusing. I'll just type the command which is written in the lab manual: gcloud container clusters get credentials. And here, what was the name of our cluster? Was my cluster. Let's do this. And okay, we have the authentication credits. So now what we can do is we can first of all check my progress here and get our points. You must have a score of 25 by now. Let's get this over with. And now what we have to do is we have to deploy an application to the cluster. To deploy an application, as I mentioned previously, you have to use these containers, and from the Google Cloud Container Service, containers registry service. But has for now, like setting up containers on a window or on Windows or a Mac, your own machine, takes a little bit of time, setup and all. So we will just use this pre-made container to do the rest of the stuff for us. Let's just copy this command from here and paste it, and let's just hit enter. It will create a deployment server with that container. Okay, and it's done, just like in a second or all. Check my progress, and you should be good to go with a score of 50, I guess. Let's just wait. Yep, we have a score of 50. Now this cluster that we just created, this is still private, like it's not visible to the public. So what we can do is we can expose this on a port 8080, and we also later on we have to set up a load balancer, which we will set in the next lab. So let's just do that. I will write kubectl expose deployment hello server, because this is what was the name of our deployment, hello server. And then we will set a type. Now let's say that you don't remember all the other variables, right? All the other flags. What you can do is, remember we talked previously in our previous cloud studies time session, you can use this -h command to see a manual. So here you can see the different different labels, different flags that which you can use. Right now we are using the type, so let's just search that. There must be one with type. Yep, you can see there's this type, and type for the service: cluster IP, node port, load balancer, external name. Default is cluster IP, but we don't want cluster IP. Let me just get rid of this, clear this one. And what we can do is kubectl. This was our previous command, and instead of -h, I will set a flag of type is equal to load balancer, and we want it at a port of 8080. So we can do port 8080. Just hit enter and wait for this to be exposed, and it is. So now let's get the current status of our service. Like it's exposed, but what is the external IP address and all? Let's try this. Okay, it is still saying that our external IP is pending. This is normal. Typically exposing a Kubernetes cluster takes a little bit of time. It can take around 20-30 seconds. Let's just keep on doing this, and we will receive some sort of IP address in just a few seconds. Okay, now you can see there it says this external IP address 34.71.7.6. Let me just clear and zoom in. Let me run that command again. Yep, you can see 34.71.7.6. So I will just copy this, and I will open a new tab, paste this, and what was the port that we exposed? It was 8080. Remember? So now if you press enter, you should be able to see this, and this is where we are. So what we have done is actually that container image which we passed, that hello server one. Let me just open the manual. Yep, this one. This image contains a Nginx server, and that Nginx server has these modified files, which we are able to see here. And that Nginx server is deployed and it's running, and that is why it is showing this output at this our external IP address with this port. So now let's get back to a lab manual. What we have to do next, and that's pretty much it. Let's just uh, click check my progress, and you should have a score of 75. We still have to do one more thing. We have to delete this cluster that we just created. Deleting deleting anything on cloud is pretty easy. You just have to use the delete command. Okay, now let me just find, yep, here it is. Let me just clear this, get rid of this one, and now we can write g cloud container clusters delete my cluster. Okay. And we should, yep, it is asking for a warning, a prompt. Let's say yes, we want to delete our cluster. And after a few seconds, you should, when you refresh this, you shouldn't be able to see any clusters here. Let's just wait for a few seconds. Okay, until this is working, this is taking a long time. Would you guys like to share? What's your progress for now? How many quests you have completed? How many skill badges you have earned? Has anyone earned? Has anyone completed the first track? The whole first track, a 6 quest. Actually, I received a few stats, and around 4 people have completed the. Oh, okay, that's great, Chagrit. Awesome. You should be on the leaderboard. We are currently, actually, also Chirag asked about the leaderboard. We are currently working on that one. Actually, we are just creating it. Just give us some time, guys, and we will. Okay, Chirag has completed the full AI ML track. Wow, man, that's terrific speed. Kudos. So, as I mentioned, as I was saying, we are currently working on the leaderboard one, and we will share it as soon as it's done. It's taking a little bit of time to do all the backend job. Yep. This is taking such a long time. Like the last time I attempted this, just took around 40 seconds or something, but today it's taking so long. Also, is has anyone registered for DevFest? If in case you guys don't know what DevFest is, DevFest India. DevFest is like this annual mega event from Google developers, and like it's in this year. Usually every year it's an event where you have to go, like GD Chandigarh and GD Jalandhar organizes previous year in Chandigarh, and there you can meet and attend sessions for by Google developer experts and all. And but currently this year, because of these unprecedented times, we have the whole DevFest online, and around 50 communities are coming together to organize this. In case you haven't, just go and register for this one. It's going to be amazing, and you can also earn some sparks and all. Finally, thank God, our cluster is deleted. So okay, I will just share this link in case you want chat. Okay, many of you have already registered. That's great. Now let's open our lab manual. Click check my progress, and you should have a score of perfect 100. So congratulations, you just deployed your first containerized application using Kubernetes Engine. Let's click on End Lab. And I will also close this incognito window. Just leave this. Yeah. And perfect. Let's get back to our presentation. Give me a second. Okay, so we just completed our fourth lab. Now let's move on to the next lab, which is setup network and HTTP load balancers. So, as the name suggests, the main objectives for this lab would be to set up a network load balancer, setting up an HTTP balancer, and we will learn about what are the differences between these two. Actually, like first of all, let's just talk about what is the need for load balancers and all. What are these? So imagine that you have a very massive online shopping site, and let's just take the example of Amazon and Flipkart. The big billion day sale is going on right now, I guess, and also the Great Indian Festival sale, whatever they call Amazon, and these two sales are going on right now. So like let's imagine they have announced the sale for around 2 or 3 days, I guess, and thousands of customers, actually I would say lakhs of customers, will hit all their website at a particular time. Let's say the sale starts at 6 p.m. So everyone will just hit their website at 6 p.m. to take advantage of the sale. Now the website starts off well, but it soon becomes unresponsive because of this huge amount of traffic. And there's just so much heavy volume and sudden spikes in traffic, which can cause Amazon or Flipkart servers to become overloaded and run out of resources such as memory. Like if more than around 20 lakh people are visiting, even 684 gigabytes of RAM that we saw in our previous study jam, that won't be sufficient to handle all the load. Okay, so in these cases we use load balancers. Load balancing is basically the process of distributing network traffic across multiple servers and multiple virtual machines, and this ensures that a single server is not overloaded by heavy demand for your application. By spreading the incoming request evenly, load balancing improves the responsiveness and reliability of your website or your application. So let's again jump right into our browser and see this in action. Here's where we were, and we have this lab, setup network and load balancers. Just click on this one. Let this open. And again, we okay, you can see here in the object, in the overview, we have these two network balancers, these two load balancers. The first one is network load balancer, and the second one is HTTP load balancer. Now, what is the difference between these two? That is what we are going to learn in this whole lab. But to just give you a brief intro, the major difference between network load balancer and HTTP load balancer is, let's say, network load balancer is region specific. Let's say, for example, if someone in US is trying to visit Amazon website, then they will redirect that person to another domain. Like if you try to open amazon.com in US, it will open up amazon.com because that's the US specific Amazon domain. But in case you open amazon.com, it will show you a pop-up to redirect to India. That is because of these network load balancers. What they do is, based upon region specific request, they will redirect to a different server which is in that region. So that, like, if in case you have used Netflix, like you must stream Netflix a lot in this lockdown also, especially. So whenever you open Netflix, let's say you open Netflix in India, there is different content. But if you go to Canada or US or any other country, and there you open Netflix, the content is different. Why is that? And that is actually mainly because all, like, first of all, the content is region specific. Secondly, whenever you are trying to visit netflix.com, it redirects your request to a server which is based in that particular location. Now each server contains some different types of data and all. That is pretty much about network load balancers. And in case of HTTP load balancers, the redirection of your request is based upon the type of data that you are requesting. For example, on my web application, if someone is trying to send a request to my database, then I will redirect them to a different server. But in case someone just wants the front end code for my website, I will redirect them to a different server. And in case someone wants, let's say, images from my website, I can redirect them to a different server. That is a brief difference between how these two load balancers work. So let's click on Start Lab, and it approximately takes around 40 minutes. But as you guys know, it does not. Like previously, and someone posted in Slack, I think it was Garima, that there's this quest that says expert level and 1 day long. To be honest, it doesn't take that long. Like when I was going through that quest, I completed that in around 6 hours or something. So these are just average times which you can which, like, let's say these are the maximum times that you can take, or something like that. So let me just copy this link for open Google Console, and again let me open an incognito window using Control Shift N or Command Shift N. I'll paste the link, and now let's copy the username, paste it here, press enter. Now let's copy the password, paste here. Okay, click accept, just click confirm to get rid of this. Wait for country specific terms and conditions. Click agree and continue. Okay, let's get back to our lab manual, and what we have to do, similarly to how we did in the previous lab, we have to set a default zone and default region. But in the previous one, we just set a default zone, we didn't set a default region. So let's do that. Let's first just open our Cloud Shell. Let me get rid of this navigation menu. Click continue. Okay, we are just connecting. Okay, and we are connected. Let me just zoom in. Okay, let me just get rid of everything. Clear. Okay, so the first thing that we need to do is set a default zone. We can do that using gcloud config set compute zone, and let's set this to the one mentioned in the lab, which is US Central 1A. And done. Now let's just again copy this command, and let's now set a region, which is compute slash region instead of zone, and let's set this to US Central 1. Let's run that, and we are done. We have set our default regions. So let's see what we have to do next. Next, we have to create multiple web server instances. Basically, we have to create a cluster which has a group of virtual machines running Nginx servers. Okay, so what these people from Kickstart have done, they have made our, I would say, whole challenge, whole setup very easy. So, in case you remember, like the last time we set up our Nginx server in our first cloud study jams, we use this sudo apt get. Let me actually just open this. We use this sudo apt get install nginx. Remember, we use this command, right? Now, let's say I want to create 5 of these servers. I will have to SSH into each and every one of them and run this command manually to make sure that Nginx server is running. Now, when you are working in production, let's say you are working in a large scale company like Amazon or Flipkart, and you have to manage around 200 or 500 of these virtual machine instances, you can already see this is so pathetic and painful job. So what people at Google have done, like Quick Labs team have done, they have written this script, and we can use this. We can create a template, and whenever we create a new virtual machine, it will be created on basis of this, and this template will these commands like apt get update, apt get install nginx, and service nginx start, they will run itself. And so whenever we create a new virtual machine, they will already have an nginx server pre-installed. Okay, so let's just copy this command and paste it here in the terminal. Click and press enter, and we have created our startup.sh file. Now remember, as we talked previously, in case you want to see the file, you can always just see cat startup.sh, and if you want to see if it exists, you can use this ls command. So as you can see, there's startup.sh, and there's another one. So now what we can do is we can create a new instance. We can use gcloud compute, because this is a compute service, instance templates, because first of all we want to create a template for this nginx. Let's just name it, because this runs an nginx server, let's just name this nginx template. And we can also use this metadata from file. This is just setting up just a flag that we are using a startup script, and let's just set startup script is equal to startup. That was the name of our file that we just created, startup.sh. Let's just run this and authorize the request. It should take some time to do this. Okay, it has created one. And now if we open our navigation menu, compute engine, and we go to instance templates, we should be able to see something. Let's just wait for this to load. Okay, you can see we have this template, nginx template. Now whenever we use this template to create a new virtual machine, it will already have an nginx server installed for us. So the next thing that we need to do, let's just get back to our manual. We have created this instance template. Now we need to create a target pool. A target pool just basically allows you to set up multiple virtual machines at once. You can just specify the size. So let's do that. gcloud compute, as this is again a compute service, we can use target pools, create, let's say, because these are nginx pool. Let's just run this, and we should be able to see this somewhere here. Target pools. Okay, it should be here somewhere hidden or something. Let's just skip that. Now we have created our target pool. In which we specified that we want to create a pool. In which we just specified that we have to create. We want to create a pool which consists of a number of virtual machines. So let's just create an instance. Let's just specify the number of virtual machines and everything that we want. We'll use this command gcloud compute instance groups manage, because we want these to be a managed services. Create nginx group. Let's just name that, and let's say the base instance name we want is nginx. Like we want everything to begin with nginx/pool1 or vm1 or something like that. So we can use this template base instance name nginx, and let's say we want let's say right now we just want to create two virtual machines at once. So we can specify the size 2. Now in case you are a big company and you want, like, you have lots of money, you can specify size of 200, but don't do this on your QuickLabs account, or your account will get banned, because they don't allow you to just randomly speed up their servers. So for now, let's just, for the sake of now, let's just specify a size of 2, and we will specify the template that we want to use. We just created this nginx template, so let's just use that nginx template, and let's set a target pool that we just created. It was Nginx pool. Let's just run this, and this should create 2 VM instances. If we go to the VM instances one, let's just wait for this command to finish. Okay, and if we refresh this, we should be able to see something here. Yep, as you can see, now we have 2 instances here, Nginx FPXP and ZWD5, some random names. Let's just now, first of all, again reactivate our Cloud Shell, which I blatantly killed when I refreshed the browser. Okay, we are back again. Dismiss this. Now we have created our virtual machines. So let's say what we have to do next. This is done, this is done. Yep, instead of going there, you can also list this using gcloud compute instances list, but you can already see them here in the web console. This is the same info. Let's just clear this. And yep, here are the Nginx variables. Okay, now let's see what we have to do next. We have to configure a firewall. Like currently, if you open this, copy this external IP address, and you try to run this, nothing will appear because these virtual machine instances that we just created, these are currently private and not visible to the public. So to make this visible, we have to first expose this, and let's just create a firewall rule, gcloud. This is a compute service again, firewall rules, create www, because this we want to publish this on the World Wide Web, www firewall, and like this is this name, and let's allow it on a TCP port of 80. I think they mentioned 80. Yes, they mentioned the 80th port. We can just do that. This basically just allows you to create a firewall and expose this to the service to the public. Right now, this is saying took too long to respond. So our firewall rules are being created, although it says like it's done, but it still takes some time. You should be able to see them here. I guess there is an option here for firewall rules. I'm not sure. Network endpoints. Okay, it was here somewhere. Okay, let's forget about it. We will see this somewhere else. Yep, as you can see, it's running, and actually both of our virtual machine instances are running. Yep, you can see these are 2 different IP addresses of our 2 virtual machines, this one, and both of them are running. So great job. We use this to create a group of web servers, and when you click check my progress, you should have score of around 25. Perfect. Now you want to create a network load balancer between these two. Now let's say a network load balancer, as I told you, we can just specify the load of the server. If let's say if a request is coming from US, we want to redirect that person to this one, Nginx FPXP. Now, okay, let me just copy this again, and let me copy this one also. Okay, let's say that I'm trying to create my own website, this one, and I'm using these load balancers, and whenever someone from US visits this one, I want to redirect them to here, this US central one, this region, and whenever someone from India is trying to visit this website of mine, I want to redirect them here. So in these cases, I can use a network load balancer, which I can create using the command gcloud. Let me just clear this first. Gcloud compute forwarding tools. Basically, actually, you are using a IP. These include a DNS IP4 config. We won't go deep into that, but on top of that, you can create some forwarding rules. For example, if we visit this one, then this is my other website, and this redirects to you a new server. But in case you visit this will redirect to another one, and this is how everything works. So we can create a forwarding rule. These things are called forwarding rules. So we can create this Nginx LB. Let's just give it a name, and we want to specify the region, the default region to be US Central one. Okay, and we want both of them to be at ports 80 because previously in our TCP command we exposed it on a port of 80. Ports is equal to 80, sorry. And again, the target pool is the one that we created, which was Nginx pool. And fingers crossed, this should run and create some forwarding rules. This is taking a little bit of time. Let's just wait. Again, you can just copy all these commands from the lab manual, which is here. You can just copy paste this one and hit enter. That should work. So the next thing we have to do is just list all the compute engine forwarding rules that we just created. Let's do that. Okay, it's created. So let me just list whatever I have done. Again, just that same command. Now clear a bit of these. We don't want to create anything. So forwarding rules, and let's just say list. It will list out the forwarding rules that we have set. We have set this one for Nginx lib. That was the name, Nginx load balancer, and it is for this US Central One region and with this IP address. Okay, perfect. So let's see what we have to do next. Okay, first of all, let's just click check my progress, and you should have a score of 60 by now. Yep, perfect. The next thing that we now, whenever someone just tries to visit our website, then they will be redirected on the basis of their region. So next up, we have to create a HTTP load balancer. So let's just first they are asking us to do basic health check. You can do this. You can also skip this, but let's just do this. Alright. It basically checks that all our previous commands were correct and our virtual machines or our pool is exposed on the 80th port, TCP 80. So we can do this using gcloud compute HTTP health checks create, and this is just a basic check. So just let's name it that one. And this will run a check and test everything if everything is working or not. So now what we can do is we can define an HTTP service that we can use later on to create our HTTP load balancer. It's pretty easy. Gcloud compute instance groups. As this is a managed service, let's name it managed. Set named ports, and the name of, let's say it's Nginx groups because that was the name of our target pool group. And okay, named ports HTTP ED. Let's run this again. Okay, it says it not found. That's weird. Okay, maybe I just mistyped something. Let me just copy paste the command from this one. That should work. Yep, I must have mistyped something. What was the error? Okay, let's forget about that one. I just miss something. Now we just have to create a backend service for our HTTP, and that is what's written in the lab manual, I guess. Okay, so we have to create a new backend service. Okay, let's do that. Gcloud again compute backend. Sorry. Okay, again I'm I'm scared that I will just mistype something, so I can just copy the commands from here, this one, and I will just paste this here. Click enter, press enter, and we now have a backend service with this name Nginx backend. Now we want to add the instance group into the backend service that we created. I know this is tiring, but we have to do this. So let me just use the command gcloud compute URL maps. Sorry. Okay, what's happening? My keyboard is not working. Yeah, gcloud compute backend services add backend Nginx backend and instance group Nginx group. Sorry, what I'm writing. And instance group zone as US Central 1E and global. Let's just press enter and it should work. Okay, great. We have now created our backend service and linked it with our HTTP. Now we want to create a URL map. A URL map basically contains all the different URLs that you want to use. For example, let's say I am google.com and I have different URLs, google.co.in, google.com, and for other country specific regions, I have google.co.pk or maybe some else. So for this, we can use URL maps to create a list of different URLs and map them to specific services. Now, a simple example would be, let's say I have this database .shandeveloper.com, and I'm storing my database here. And whenever someone wants the printing code, I'm storing that here. And let's say whenever someone tries to visit blog.shandeveloper.com, this website of mine, I will get all the front-end code from here, and I want to get the database from here. In that case, I will create a URL map to map everything to their specific VM instance IP address, which I can do using gcloud compute URL maps, create web map, and set a default service with Nginx backend that we just created. Okay, and now this should direct our traffic to different requests, like based on the request. Now we just have to create a few more things. HTTP proxy, we won't go into detail because that is a vast topic. Let's just copy that command. But in case you want to know more about it, just ping me on Slack. But I'm thinking it's not good to cover these for the rest of the audience because these are some advanced topics. So also again we have to create a forwarding rule like we did previously. Let's see what's mentioned. This is what I did right now, and now we have to create forwarding rules. Let's do that. Gcloud compute forwarding rules. Create HTTP. Let's name it HTTP content rule, and this is a global one. Let's set the target to the proxy that we just created. HTTP load balancer proxy, and let's set the ports to 80. This should work if I didn't mistype anything. Okay, it's done, and now we can list all these forwarding rules. Gcloud compute forwarding rules list. Yep, we actually need this IP address. Let me just copy that, and I will just paste this here for now in a new tab. We might need this later on. Okay, so this is our this is still running. Let's just try again. Yep. Let's just try to visit this one, and this should work. Why is this not working? I think it should take around 3, 4 or 5 minutes. Something. Oh, okay. Sorry. I think it's working. Let's just check our progress. Maybe this is the default page that appears. Okay, it's working. Okay, the reason was like this is the default page that they have set for everything. This is the server, and let's say this image is stored on one of our VMs, and this is stored on another one, and the front end code is somewhere else. And we just click check my progress, and voila, we have a score of perfect 100. Now, anyone knows the answer to this one? Network load balancing is a regional non-proxied load balancer. Can anyone write in the chat? I'll just share the question. Okay, Dipali says true. Chirag says true. Sanjita also says true. Let's try true. Anyone saying false? Okay, everyone says true. Rajat also said true. So let's try that. Yep, correct. And with that, we have finished the 2 remaining quiz that we have for today. So let's get back to the PowerPoint presentation. This is how our progress should look by now. And next up is our challenge lab, which is getting started, create and manage cloud resources challenge lab again. And in this, the main objectives of this lab will be to create an instance, create a 3-node Kubernetes cluster, like just we use right now. We just created Kubernetes Engine previously, and you will then again need to create 2 HTTP load balancers for 2 web servers. Just you can try this on your own till Sunday, which is the after tomorrow. And in case you have any queries or any issues with this, just reach out to me or anyone from DSC on Slack, or just post your queries there, and we will try to help you out. Or we can also schedule a session on Sunday for all the doubts and everything. So this is a schedule for the rest of that. After Sunday, we will be having our next study jams on Tuesday, as promised, and the next one on Friday. So again, as I mentioned previously, as I have been mentioning from the past 3 online sessions, we are working on creating this leaderboard. And in case you would like to participate, you can use this link. I will just share that in the chat. bit.ly/30days leaderboard. Yep, you can sign up here in case you haven't, and the top 5 students on this leaderboard will receive some extra goodies from the DSC team. So that's pretty much about it, and I hope you enjoyed. I know it got a bit boring in the end, but there were so many things that we couldn't discuss about, like HTTP target pools and all. But I just thought that was out of the scope of this. In case you want to learn more about that one, just reach out to me on Slack or anywhere else, and I will try to help you out. Okay, let's see if we have any questions. Shirag is asking, the DSC team members like you would also be shown on leaderboard. I won't be shown on the leaderboard, but yeah, for the rest of the people, they will be shown on the for the rest of the team members, they will be shown on the leaderboard. Okay, Vaibhav is saying, for the opportunity to plant a tree by performing hackathons. Great, man. Like you sacrificed your T-shirt for that tree. That's great. Congratulations, and Please share your screenshots, your Hacktoberfest profile screenshots in the Slack, and we would love to see your victory. Awesome. Congratulations once again. And congratulations on helping the planet. Okay, any more questions? Okay, Chirag is asking how to plant a tree. Please tell me also. Basically, when you complete the Hacktoberfest challenge, you will receive this form. With like in that you can fill a choice whether you want to get or earn a T-shirt, or whether you want to plant a tree in your name. That's totally up to you. Whatever you want to do. Like most of the people go for T-shirt, but in case you care for the planet, you can also choose to plant a tree. But no one is judging you. It's totally up to you. Sanchita says thank you. Thanks, man. I'm glad you enjoyed it. No issues. Okay, I will just have a countdown for around, let's say, 15 seconds. In case anyone has any more questions, please share them right now, or else we will be ending the session. Okay, bye, Vaibhav. I guess no more questions. Okay, thanks, Rajat. I'm glad you liked it. So thank you again, and catch you all in the next one. Peace. Keep hacking and have fun.